The other project then called Old Faithful.
Ooh, this one is hands down.
Right? Yeah,
it's the big one that is the hot topic. And yes, please share all the details about Old Faithful, how it works, and how the I guess relationship with Protocol Labs and how that kind of came about. I'm very curious.
Yeah. So, and to kind of lay the stage for the conversation, a developer when they're new to Solana, they're starting to learn how it works. They want to start writing some code. They may also be interested in running their own RPC stack. And so they want to be able to spin up an RPC server, learn about that, and then write their application against their own server. What they quickly learn after that is they do not have access to the history. So you don't get access to the full ledger of Solana going all the way back to Epoch 0, Block 0, right? And that kind of sucks. You should be able to spin up an RPC node on a blockchain and have visibility into the history. That's what blockchains are about, right? And at the moment, that history is in Bigtable, in Google Bigtable. And there's only, I don't know if there's 5 or 6 people that have instances or replicas that we're all maintaining independently. And that means that if you want to get the history, you have to go through a gatekeeper. And that kind of sucks that, you shouldn't have to go through a gatekeeper to get to the history that should be there. So Linus Kendall, one of our co-founders, along with Richard Patel, many people know Richie he's on the Fire Dancer team, amazing engineer. And the two of them were talking in London a year and a half ago at St. Pancras Station. We're just going to call it the St. Pancras meeting because this is where it all started. and they were talking about ways and ideas to make this archive history available and to do it in a way that we could deliver the data at a large scale because this, Solana has got a lot of data. Especially compared to other blockchains. So they did some napkin engineering.
Terabytes right now, something like that.
Yep, currently
and
about
that's
250.
Just on one cluster.
250 terabytes right now is what we've got in the Old Faithful archive. Yeah. Those guys did the engineering work, just napkin engineering, right? To say, hey, if we could do it like this, we could do that. We can use this file format. And then they came up with some great ideas. So that's the problem that we're trying to solve is that we want to make the history available for anybody in the ecosystem to be able to spin up their own RPC node and get access. Let's see. You had asked about Protocol Labs. So this is kind of where Filecoin enters the conversation, which is really cool because now we've got 2 layer 1s that are working together and collaborating in a very positive and synergistic way. So
actually, real quick, do you mind if I set the stage on Protocol Labs?
Great, yeah.
Most people don't know of Protocol Labs. They know of their I guess I'll call it a product, I guess. So Protocol Labs is the organization that's behind IPFS, the Interplanetary File System, which Filecoin is I guess I'll call it the monetary layer backing IPFS. So it incentivizes people to pin that data, to post that data that's uploaded to IPFS. And Filecoin incentivizes them financially to basically serve that data. So the Protocol Labs that's kind of the background on them for those of the listeners that don't know.
Yeah. And so it was a good conversation. I believe it was Richie Patel who said that, hey, we should use IPFS. We should use Filecoin. And there's a file format that he recommended called a CAR file format for archiving. The point being is that it's content addressable. And the reason that it works well with Filecoin is that we can throw a 500 gigabyte file onto Filecoin. And if you need to pull a transaction out of that 500 gig file, you don't need to download the entire file. you can say, I want to grab only these bytes. So there's 1K of bytes in the middle of this file. Just send me those. So that means that we can actually get realistic and reasonably good download speeds coming from IPFS. That same format is also available, or works well, I should say, on any S3 compatible storage, because S3 will support an HTTP range request. So you can say, out of this big file, give me these 1K bytes starting here and ending here. And so then by getting all 250 terabytes and growing, because it grows by 500 gig every 2 days, getting that loaded out onto publicly addressable storage like that means that the developer who's trying to spin up their own little RPC node, they don't need to have 250 terabytes or 500 terabytes or a petabyte of storage, because it's already out there in a way that they can access it. And that's huge. That's what we were going for.
Yeah, just let that sit in. Let that settle in, listeners. Like, that is such a massive undertaking and is such a lift for the Solana ecosystem that most non-developers won't appreciate that, I think, unfortunately. But I think like any developer, they would think about like the implications of that, and it is huge. This is a massive undertaking, and it's so amazing.
It's kind of the linchpin for like the crypto dream, right? Is to have all of this information decentralized, but also easily accessible at the same time. Mm-hmm. Right. Mm-hmm. Yep. And before it's like, and without this, the information still exists. And if you can get access to that information, you can verify, that sort of follow the chain, to make sure it's all accurate. But it's challenging to do, right? Like it's a very non-trivial task. I would never, I consider myself a decent engineer, and I would never undertake that task without a really good reason,
right?
Really good incentive. But to make that possible is huge. Mm-hmm. It's all like, I'll give you an example, right? Like one of the challenges with like state compression right now is that if you aren't indexing compression events as they're happening, you will fairly quickly lose access to those transaction logs, which is where the data actually lives. Mm-hmm. And so it's like it's this weird thing where like, well, it is on chain because it went through the chain and it lives on the chain state somehow, but not in like a readable form.
Right.
And so this is one of those things where it's like, you could go back and say, hey, this is the transaction where it happened. I can look at the logs. I can verify that this compressed NFT actually has the data that it says, independent of the indexing that sort of exists with the DAS API and stuff. So now there's sort of multiple entry points for confirming this or verifying the accuracy and validity of data, which is really awesome.
Yeah. And so this project, we're really focused on the data availability layer, but not the data delivery layer. And data delivery might be where you have performance come into play. To say, okay, great, I've got access, but now I want really, really fast access. And, but it's that same file format, since it's so portable, that, you could, if somebody wants to download it from Filecoin and put it into a nearby S3 storage, they can do that. If they have a really big data center with petabytes of storage, then of course they could even bring it in local and still access it, the same way. So that's all pretty cool. The one catch though is the index files are pretty big. So
I can imagine.
Yeah. So out of the 250 terabytes right now, there's just over 50 terabytes of indexes. Wow, so it's still not a small lot. Yeah.
Interesting.
It's not a Raspberry Pi kind of thing.